Hi guys, welcome to the very first module, that is time and space complexity analysis. As the name suggests, in this next couple of videos we will try to understand what exactly are time and space complexities, and we will try to understand what are the different steps that we need to follow for calculating the time and space complexities of the different functionalities that we will be implementing on our data structures implementations. Okay, with that being said, let's just dive into understanding what exactly is time complexity. So the time complexity of an algorithm is nothing but it actually defines the amount of time that an algorithm takes for giving the end result, or else the amount of time it takes to execute. For example, let's just consider we have written a function called add array, which will basically take the array of values, and in the end it will try to return the sum of all the values that we have in the array. So as part of the time complexity analysis, what exactly we will do is we will try to analyze the amount of time this add array function is going to take based on the values that we have gotten in the array. Okay, so that's what time complexity analysis is all about. And the second important thing that you have to know is it basically explains how our algorithm is going to vary based on the different input variations. What do I mean by that is whatever the add array function that we have written, right, in the array of values that we are going to get, the array might have no values at all. The array might have 10 values, array might have 1000 values. So as part of the time complexity analysis, what exactly we want to derive is how our algorithm is going to vary for the different input sizes. Is it going to take same amount of time even if I pass 1000 values and 10 values, or how the algorithm is going to, how the amount of time taken by the algorithm is going to vary based on the different sizes of the input that I am passing for the execution. Okay, so that is the second point. And the next point that we have to remember in terms of time complexity analysis, as part of this time complexity analysis, we will not calculate the exact amount of time that the algorithm takes. What do I mean by that is, whatever the add array function that we have written, right, as part of the time complexity analysis, we will not say our algorithm is going to take 10 seconds for the array size that has 10 elements. Rather, we will not say our function will take 1 minute for the array that has 1000 elements. We will not try to give the exact amount of time in a unit. Okay, rather we will try to analyze and we will try to come up with a mathematical representation that basically defines the units of time it is going to take. Here the unit is not actually the time metric that we have. It is a mathematical abbreviation that we will be calculating. Okay, so as soon as you look at the definition of time complexity, we are saying that we are going to analyze the amount of time taken, right? That's why people will often confuse and say that, we are going to calculate the exact amount of time. No, we will not be doing as part of time complexity analysis. We will never try to pinpoint that our algorithm is going to take X seconds of time or whatever. Okay, but rather what exactly we will do is we will try to graph the units of time our algorithm is going to take with respect to input size along with the amount of time taken, which will basically give us the overall time complexity analysis of our function. What do I mean by that is we basically try to draw a graph. On the x-axis that we have, we usually take the input sizes, okay, and on the y-axis we will consider the time taken. So for the input size that we have got here, right, so basically first we will pass array that has only one value and we know how much amount of time it is going to take, right? So based on that, based on the different sizes that we pass to this add array function, we will try to graph the amount of time taken. So this is nothing but the whole time complexity analysis of the algorithm that we have written. Okay, so at this point of time, don't worry about how exactly we are going to draw this graph and all those things. In the next couple of videos, I will try to show you very commonly used representations. At that point of time, we will try to, analyze the time complexity analysis of very commonly seen algorithms. Okay, so that is something that you have to remember. So let's just try to revise here. What exactly is time complexity? Time complexity of an algorithm is nothing but the amount of time taken by the algorithm, and as part of the time complexity analysis we will try to analyze how our algorithm is going to execute based on the fluctuations in the different sizes of the input. And the third important thing is, as part of this time complexity analysis, we will not exactly calculate the time, rather we will try to reach a mathematical representation of our time complexity analysis of our algorithm. And as part of the time complexity analysis, we will try to plot a graph with the input size and the time taken by the algorithm so that we can reach that end mathematical representation. Okay, now that we know what exactly is time complexity analysis, let's just try to understand why exactly we do a time complexity analysis on the algorithms that we will be implementing. So the very first reason why we would do is basically we want to define the efficiency of the algorithm that we have written. So basically software engineering is all about making the betterments in the implementations that we have already done, right? So we can do any betterments in the already implemented logic once we try understand the efficiency of that particular algorithm. That's why to see the possible betterments that we need to do for the existing implementation, we will try to analyze the time complexity so that whatever the implementations that we have done, right, we can make the betterments in that implementation. As a result, the scaling of the application will also gets improved. Okay, so for example, let's just try to analyze one simple algorithm. I may have written one function called find root. Okay, this find root basically takes 2 points a and b, and it will try to find the appropriate route for starting from point A to reach the point B. Now whatever the algorithm that I will implement in this function, right, first of all I have to analyze the efficiency of this algorithm. Basically the journey involves calculating the weather conditions, traffic, road situations, and all those things, right? So whatever the considerations that we have done in this case of implementing the find root function, we have to analyze the efficiency so that if we have any betterments that we can do, we can fine tune those parameters and we can make the algorithm better. As a result, the implementations that I have done in the beginning, right, for every user whoever is trying to use this find root function, they might be taking n units of time for finding the route from A to B. But if I try to make the appropriate betterments in my implementations, this might only take n by 2 units of time. As a result, whoever uses this find root function, we have basically reduced half of the time, right? So it is very important that we understand the efficiency of our algorithm such that we can make the betterments so that we can scale the applications. So that is the reason why we do the time and space complexity analysis of our algorithms that we will be implementing. If our main aim of analyzing the time and space complexity of an algorithm that we will implement is to find the efficiency so that we can make the betterments in the algorithm, right? So if that is our main aim, why not we directly calculate the amount of time taken by the algorithm directly, right? Because if we know the time, that will become much more reliable metric so that we can decide the efficiency. Because saying that the algorithm takes n units of time is a bit difficult than saying our algorithm takes 10 seconds for execution, right? So giving that amount of time taken by the algorithm directly makes much more sense. So why don't we rely on the calculation of the time rather than deriving all these mathematical implementations and trying to plot all the graphs? Why exactly we are doing that? So the very first reason why we are doing all this analysis is because we have a different systems. For example, let's just assume that the team that I am working is having 10 people. Okay, so as part of these 10 members, I might be using a system which has 8 GB RAM. Some other team member might be using 8 GB RAM with some latest advanced processor, and some other person might be using a different computer which has all these functionalities with a super fast operating system. So the amount of time taken by the algorithm in 8 GB system is different. The amount of time taken by the algorithm in 8 GB with latest processor is going to be different, and it is going to be different even on the super fast operating system as well. So the amount of time taken by the implementation that I am doing is different in different systems. So if it is different in different systems, how can we generalize and say it is going to take X units of time directly, right? So that is the first reason why we don't rely on the calculation of the time directly. And the second reason why we would do it is basically because the amount of time taken by the algorithm for execution is basically impacted by the internal processor running. Why? What do I mean by that is, maybe I'm using a 8 GB system. In 8 GB system, while running the program, I might be running some music. I might be, you know, editing some videos. I might be trying to encode them. So after all, whatever the RAM that our program is going to take for the execution, right, is getting impacted by all these processor. So the amount of time taken by my program, I mean the same program on 8 GB, in which the internal processor are being consumed by music running and encoding the video, is going to be different from a 8 GB latest processor system which has nothing running in it. Okay, so all the RAM that is available will be given for the program execution directly. So obviously my program execution will be faster in the 8 GB system which has latest processor than the system which is running music encoding of the video as well as trying to run the program that I have written. So basically we have some load on the system which is basically impacting the amount of time taken by the algorithm to execute. That's the reason why we don't rely on calculating the time directly taken by the algorithm, because we have different systems available, and in each and every system also the person might be doing some background work which can impact the amount of time taken by the algorithm. So those are the reasons why we will not rely on calculating the time taken by the algorithm directly. Rather, we will try to derive the mathematical expression which basically gives us the sense how the algorithm is going to work in terms of different sizes with respect to the amount of time taken by the algorithm. Okay, so that's all you need to know, why we don't rely on calculating the time directly for defining the efficiency of an algorithm.